Proving lines are parallel. Let's recall what we already know. We have a postulate, the corresponding angles postulate, that says if two parallel lines are cut by a transversal, then each pair of corresponding angle is congruent. We also have theorems that are proven based on the postulate that if you have parallel lines, then alternate interior angles are congruent, that consecutive interior angles are supplementary, and alternate exterior angles are congruent. So now we will be proving lines are parallel based on our angles that are given to us. We have a new postulate. It's the converse of the corresponding angles postulate. It tells us if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. Remember that a postulate is something that is accepted as true without proof. So based on this postulate, we can prove that lines are parallel if alternate exterior angles are congruent, consecutive interior angles are supplementary, alternate interior angles are congruent, and we have the perpendicular transversal. Says if the transversal is perpendicular to two lines, then those two lines must be parallel. Let's do an example. Find the measure of angle MRQ so that line A is parallel to line B. So based on this, we have algebraic expressions for angle MRQ and for angle RPN. Those angles, if you'll notice, are alternate interior. So if we want to prove that the lines are parallel, then we want to show that those angles are equal. And so we can write our own equation, setting them equal to each other, solving for x, and then we can plug it back in to get the measure of angle MRQ. So here, the measure of angle MRQ is 77. Here is another example. Find x so that line M is parallel to line N. So we look at our diagram and we see that our algebraic expressions are for alternate exterior angles. If we know that if alternate exterior angles are congruent, then the lines will be parallel. So we can write our own equation, setting those algebraic expressions equal to each other, solve for x, and then we will know the value of x so that lines M and N are parallel. For this type of problem, it says determine if R is parallel to S. So we'll look at it and we see that we have a 64-degree angle and we have two 32-degree angles. If we add the two 32-degree angles together, we get 64, and so that whole angle of 64 degrees is equal to this other one that's marked 64 degrees. Those two angles are corresponding angles, and according to the postulate, then we know our lines are parallel. For this example, to show that lines R and S are parallel, we want to see if these angles add up to these alternate exterior angles, like together they make the alternate interior exterior angles. So if we add them together, we'll know if they're congruent or not, and then we'll know whether R is parallel to S. So we do see that the angles are the same, and therefore R is parallel to S. For this example, again, we're looking to see if R is parallel to S, and we see that these two angles together are alternate exterior angles with the 92 degrees. So if 65 and 27 add to 92, then we will have congruent alternate exterior angles, and the lines will be parallel. I want to show you this last example. It points out an error that is often made when looking at a figure and noticing what lines are parallel and then determining which ones are actually parallel, especially if there are multiple lines in the figure. So let's start off by reading the problem. Error analysis. Sumi and Daniela are determining which lines are parallel in the figure at the right. Sumi says that since angle 1 is congruent to angle 2, segment WY is parallel to segment XZ. Daniela disagrees and says that since angle 1 is congruent to angle 2, segment WX is parallel to segment YZ. Is either of them correct? Explain. Pause the video and see if you can figure it out first. Let's see how you did. Daniela was the right answer. She was the one that was correct. She said that if angle 1 and angle 2 are congruent and they are alternate interior angles, and they're formed by the lines WX and YZ with the transversal WZ. And so that therefore the WX and the YZ are the parallel lines. The reason that Sumi was wrong is she said that angle 1 and angle 2 are congruent and therefore WY and XZ are parallel lines. However, WY and lines XZ don't even form those angles, so therefore they can't be the ones that are parallel.